Welcome to the Explainer. So today we're tearing down a massive industry-wide assumption. We are going to dive straight into the wild hype surrounding context files for AI coding agents. You probably know them as agents.md or Claude.md files. Well, we're going to uncover the pretty shocking truth behind this exploding trend.
Right now, if you look around, tech giants and leading AI frameworks are heavily recommending that you tailor your coding agents by feeding them these specialized context files. It's touted as, the ultimate way to adapt an AI to your specific repository. But we don't just accept things at face value here, right? We really need to ask, is this accepted best practice actually working? Or is it just creating an illusion of competence?
And the scale of this trend? It is absolutely staggering. We're talking over 60,000 public GitHub repositories that have already just blindly adopted this practice. They're enthusiastically adding these context files to their codebases. It's basically become a foundational step for modern software engineering with AI. But think about it. What happens if that foundation is completely flawed?
So the crucial point here is understanding exactly what these files are in the first place. Essentially, think of them like a highly specific onboarding manual, but designed strictly for an AI. Instead of a human developer reading it, the agent uses it to align itself with your specific codebase. It's supposed to learn your specific tooling, how you format things, and exactly how to run your unique tests.
Here's our roadmap for today's explainer. 1. The context file craze. 2. Putting agents to the test. 3. The surprising results. 4. Why more context hurts. And 5. The final verdict. Let's get right into it.
Sections 1 and 2. The context file craze and putting agents to the test. Let's look at how a team of researchers finally built a real-world test to see if these widely recommended context files actually deliver on their lofty promises. You see, until now, we really haven't had a rigorous way to test this, mostly because the trend is just so incredibly new. The old rulers, established testing benchmarks like SWBench, they simply don't fit because context files didn't even exist when they were made. Plus, testing on highly popular, massive repositories doesn't exactly represent the average niche code base that most of us actually work on day to day. So researchers engineered a really clever solution. They built AgentBench. It's a brand new benchmark crafted directly from real, niche GitHub issues that actively use these developer-committed context files. To give you an idea of the scope here, AgentBench sourced 138 unique Python tasks directly from 12 real-world repositories. This is huge because it proves we aren't just looking at some narrow, artificial, or sterile test environment. This is genuinely as close to real-world software engineering as it gets. Moving on to Section 3, the surprising results. Okay, let's dive into the absolute core of the experiment. This is where top-tier AI models face off to solve coding tasks, both with and without their precious instruction manuals. Now, logically speaking, you would totally expect these comprehensive manuals to increase both the success rate of the AI and the speed at which it solves the problem, right? I mean, that's the whole point. But the raw data reveals a massive, entirely counterintuitive plot twist. Just look at how the performance physically steps down when LLM-generated context files are introduced. It's crazy. Across multiple state-of-the-art models like Sonnet 4.5, GPT 5.2, and Qwen 3, performance actually drops by 3% on average. So essentially, following this industry best practice of generating these files with an AI literally makes your agent worse at fixing the bug. Comparing the two ways these files are created reveals a pretty harsh reality. LLM-generated files don't just make things worse, they actually increase your inference costs by over 20%. But wait, what if a human developer writes the file? Well, human-written files do provide a marginal performance boost. We're talking about 4%, but they still hike up your running costs by up to 19%. So you are paying significantly more for barely any gain, or in the case of the LLM-generated files, an actual measurable loss. Section 4. Why more context hurts. And this brings us to a really crucial question. Why in the world would giving an advanced AI more instructions make it perform worse, and crucially, cost 20% more money to run? Think of the AI as an overeager intern on their very first day. If you hand them a massive, incredibly detailed company manual, they are going to follow it way too well. They end up wasting valuable time reading the entire thing, double-checking every single detail, and just totally over-exploring the codebase. All of this instead of just looking at the bug right in front of them and actually fixing it. And the forensic proof of this behavior is right here in the data. Notice how those tool usage metrics extend way out.
When you add context files into the mix, the AI starts using its tools incredibly excessively. We're talking running way more tests like PyTest, reading significantly more files, and searching through tons of directories using commands like grep. It literally burns through computational steps and your money just going down rabbit holes simply because the context file basically told it to be thorough.
Because of all this massive overexploration, models like GPT 5.2 ended up spending 22% more reasoning tokens just to process these generated context files on SWBench Lite tasks. Let that sink in. That translates directly to slower response times and significantly higher API bills for you, the user, with absolutely nothing to show for it.
And we have to talk about a very specific problem here, the overview illusion. When asked to generate a context file, models like Sonnet 4.5 include these massive codebase overviews literally 100% of the time. But the data unequivocally shows that this redundant documentation doesn't actually help the agents locate the problematic files even a fraction of a second faster. It is quite literally just noise.
Now, to be completely fair to the data, there is one very distinct exception to all of this. If your codebase is an absolute mess with absolutely zero documentation, which the researchers tested by literally manually deleting every single Markdown and Docs file, then an LLM-generated context file suddenly becomes helpful. It boosts performance by about 2.7%. Basically, it acts as a last resort lifeline when the AI has literally nothing else to go on.
Section 5. The final verdict. All right, let's translate all this dense data into how you should actually be handling your AI coding assistants starting today. The price of blindly following tech advice can be super high. The clear takeaway here? Completely skip LLM-generated context files unless your repository is entirely undocumented. And if you absolutely must use human-written files, keep them incredibly brief. Seriously, don't write an essay. Only include essential, completely non-obvious details like maybe a highly specific shell command required to run your tests. Get out of the AI's way and just let it focus on the code. This entire study leaves us with a really provocative thought to end on. As we all rush to scale AI coding agents across the software industry, how will they ever handle massive, million-line enterprise codebases if a simple, automated instruction file trips them up and causes them to spiral into overexploration? It really seems like the path to better AI isn't necessarily just dumping more context on it, but rather providing smarter, highly efficient context. Thanks for joining me on this explainer, and keep learning.